how we can derive the supply curve, from the individual supply curves. Okay, so this is the context. Now, having a negatively sloped market demand curve and a positively sloped market supply curve, in the next step, we will talk about equilibrium. What is meant by equilibrium in a market? Okay, now in one sentence, equilibrium means when a state when there will be no excess demand or excess supply. Equilibrium is a state when there will be no excess demand and excess supply. Now, before going to the idea of equilibrium, what is its implication? What is the meaning of uniqueness of the equilibrium? What is the meaning of stability of the equilibrium, etc.? First, please note it down. The market we are talking about is a perfectly competitive market. To elaborate the notion of equilibrium, we are considering a market system which is perfectly competitive in nature. In the beginning, I introduced different types of markets. We discussed 2 or 3 most important points which we need to mark, So I think the entire class has some idea that I said something like perfect competition. I told you about monopoly, monopolistic competition, oligopoly. Then we talked about monopsony, oligopsony, etc. So already we discussed about definition and few important properties of different types of markets. In later dates, you will learn much. However, coming to this juncture, we again need to remember the definition of perfect competition, because the idea of equilibrium, its uniqueness, its stability, everything I'll discuss considering the market to be perfectly competitive. So, is there anyone who will tell us what are the characteristics of a perfectly competitive market? When I'm telling we are talking about a perfectly competitive market, so is there anyone who will tell us?
Ma'am,
Products.
condition is when the price of the products shouldn't change as per the quantity. I mean, if I buy one product, what and if I buy 100 products, the price must remain same. It shouldn't change.
Okay, so I got some idea about Shomodev. Would you please tell us? There are many hands.
Ma'am, a very large number of buyers and sellers are there. There are homogeneous products. There is freedom of entry and exit. There is perfect knowledge among the buyers and sellers. There is perfect mobility of factors of production. There is absence of transportation cost, and there is absence of selling cost.
Okay, very good. Only 1 or 2 points left. So there were many hands and I'm not getting any more. So would you, yeah, Bidusha or Manzoor Alam, anyone? Manzoor, would you please tell us?
Ma'am, usually firms have all the knowledge about the product market and the factory market, and buyers are
Complete
also having perfect
information.
knowledge about the
Yes,
product market.
yes, yes. Very good. Anything else? Niladri, yes.
Means, ma'am, in a perfectly competitive market, no, a single individual cannot influence the price of a product.
Yes, Shomode mentioned about that point, So in the beginning, we talked about something, about this. Yes, Dorjoy, Pema Dorjoy.
And entry of returns are free, even the exit are free.
Yeah, so Shomode
Ma'am,
mentioned about this point. Entry and exit are totally free. Yes,
ma'am,
Srishti, Manzoor, just
ma'am, we can also
Yes,
say
ma'am.
that.
Srishti, yes.
Yeah, there are only normal profits in the long run, like no super normal profits.
Okay, this is not the characteristic, So when we talk about the equilibrium, all these things will come up. However, this is not coming in the definition or the properties of the perfectly competitive market. Manzoor, yeah.
Ma'am, we can also say that the product of one unit is the perfect substitute for the others. And this ensures that the price is uniform in the market.
Yeah, yeah, definitely. Shomodeep, in the beginning mentioned it is are homogeneous in nature, so already this point is with us. However, you elaborated it. Saina, yes.
Ma'am, as a conclusion, we might say that price is determined by the industry through the tools of market demand and market supply.
Okay, okay. So I think nobody mentioned about there is no government intervention. Okay, so if I just sum up your points, so a perfectly competitive market is a market where no individual has any role to determine the price. Price is given from outside the market. Actually, what happens, what Sina started to tell, so from the market the price is going to each of the firm, etc. Okay, so to begin with, we will say that both the demanders and the suppliers have no role to determine the price because there are numerous buyers and sellers in the market. So if a single individual changes demand, if a single supplier changes supply, there will be no impact on the market. Okay, so this is number one and very important to all of us. Number two, there will be complete information about the commodity and its prices, both for the buyers and the sellers. Okay, so last day we talked about incomplete information, asymmetry in the information. We talked about the second-hand car market, which we call the market for lemons. And we also talked about the market for health insurance. Okay, so we talked about all these markets where information is incomplete. Buyer has lesser information or seller has lesser information. So under perfect competition, there should be nothing like this. The information will be complete both in the part of demander and the suppliers. Number three, there will be no intervention from outside. In other words, there will be no government intervention. The market is totally free. Entry and exit are totally free. Commodities are homogeneous in nature. So all these things, you together covered. So these are the properties of the perfect competition or perfectly competitive market. So when I am talking about market equilibrium, very much we are assuming this kind of market. Okay, so we are not talking about the monopoly, we are not talking about the monopolistic competition, we are not talking about the oligopoly. Later, when we will discuss about the properties of different types of markets, etc. In that case, you will find that there is markets, where there is no supply curve at all. When we will talk about monopoly, you will find that in a monopoly kind of situation, there will be nothing like market supply curve. So under perfect competition, we can have the demand curve and the supply curve the way we described the demand and the supply curves. So when we are talking about equilibrium, where we need both the demand and the supply curves to begin with, very much we are talking about or assuming that the market we are talking about is perfectly competitive in nature. Sorry. So under perfect competition or under a perfectly competitive market, equilibrium is a state when, number one, there is no shortage, number two, no surplus, and equilibrium price clears the market. That is, equilibrium price is the price where the market demand is exactly equal to market supply. Okay, that is a price where the market will be cleared. the aggregate demand is exactly equal to aggregate supply so that market clears. So we can define equilibrium state as no shortage, no surplus, and we should have a price which clears the market. A situation of equilibrium is defined as one all the endogenous variables are in a position of rest. All the endogenous variables are in a position of rest. Okay. Now, what are the endogenous variables both for the demand and supply? Anyone? When I'm
And
talking
Price.
and
Price.
price. Okay. So both price and quantity are endogenous variables. Price determines quantity, quantity determines price. So there is 1-to-1 relationship between price and quantity. If there is any change in price, quantity will change, be it the quantity demanded, be it the quantity supplied. So finally, when we bring demand and supply together, we should consider quantity and price. These are the two endogenous variables in the system. For both the variables, we find that quantity is determined by price, and on the other hand, quantity affects the price. If you start with the price, the same story, price affects quantity and is affected by the quantity. Okay, so both for Q and P in a demand supply system, we find that if Q changes, P changes, if P changes, Q changes. Therefore, both the variables are considered as endogenous variables. Okay. Now, to define here, I have used two new terms, shortage and surplus. So what is the meaning of surplus and shortage? Surplus, price P, if price P1 is higher than P0, from where we are getting the prices? From this diagram. In this diagram, we are measuring Q along the horizontal axis, price along the vertical axis, and we are drawing conventional demand and supply curves. That is, demand curve is negatively sloped, whereas the supply curve is positively sloped. You can consider the straight line demand and supply curves, or you can consider the curvilinear demand and supply curves. Okay. However, the story will not change if the demand curve is straight line vis-a-vis if it is a curve like this. And similar thing will happen for the supply curve. So there is this state, where the two curves are cutting each other. So at this point, aggregate demand is exactly equal to aggregate supply. So this point is called equilibrium. Now, if price is P1, what we are finding that if I drop a perpendicular from this point on the horizontal axis, this will be the demand at P1. And if I drop another perpendicular from the supply equation on the horizontal axis, that will be the supply of the commodity. So this is the supply of the commodity, whereas this is the demand for the commodity. Naturally, the supply is greater than demand, and this extra amount is called the surplus. So at price P1, that is when the market price is higher than equilibrium price, in that case, we find that supply is greater than demand. And we implicitly assume if there is any surplus, in the next round, the producers will reduce their supply. Okay, producers will reduce their supply. Okay. So if the price falls a little bit, what you will find that for reduction in price, demand will be encouraged. On the other hand, for reduction in price, supply will be discouraged. So there will be a reduction in supply, whereas there will be an increase in demand. So if I go on like this, as long as the price is little bit higher than equilibrium price, supply is greater than demand. So for a very small change in price, what we will find that Demand is increasing a bit, supply is reducing a bit, and continuously system will move towards this downward direction, and this adjustment of demand and supply will be stopped as soon as the price merges with this price P naught. Next, if I consider a price like P2, okay, in that case, demand is very much greater than that of supply. So there is an excess demand situation, which we call the shortage situation. Supply is only this much, however, the market demand is this much. Okay. So the suppliers will be able to increase the price in this situation. Okay. And if the price increases a bit, in that case, supply will be encouraged and demand will be discouraged. So as long as price is less than the equilibrium price, as the price goes up, there will be continuous reduction in demand and continuous increase in supply, and this adjustment will be stopped once the price reaches at this price P naught. So surplus can be defined as a situation given by price P1 which is higher than P naught, and the price will fall down. On the other hand, shortage is a situation which has been described by the price P2, which is lower than P naught. And in this context, there will be a pressure on the price so that price goes up continuously. And this entire adjustment of the price stops once the price reaches at P naught. Now, so just I mentioned about if the price is off equilibrium price, then there will be an adjustment and finally the price will reach at the equilibrium price. When we are talking about in this way, implicitly we are assuming as if the situation is stable in nature. If there is an excess demand, always price will go down. If there is an excess supply, price is going up, and that in turn is reducing excess demand or reducing excess supply, and the situation is moving towards the equilibrium price. So in general this will happen. However, there is real mechanism by which this will take place, and there is also a chance for the excess demand price is continuously falling down, price is continuously increasing. However, it is not moving towards the equilibrium. On the other hand, again, it may happen that there is excess supply and for that price is falling down. However, it cannot reach at the equilibrium. So when we will discuss about the stability in detail, we will talk about all other possibilities. Now to begin with, you remember that when there is any shortage, in that case, price will go up. If there is any surplus, price will go down. However, for these kind of movements, whether the price really will move towards the equilibrium or not, that will depend on several other things. Okay, like the relative slopes of the demand and supply curves, etc. Okay, so after completing the basic definition of equilibrium, I'll talk about uniqueness, stability, etc. in detail. Now to begin with, equilibrium means when the endogenous variables are at rest, there is no shortage, no surplus, and the price is such that the market will be cleared.
Ma'am, I have a question.
Yes.
Ma'am, you just told us that at equilibrium price, market clears. What is the meaning of that statement?
Market clears means demand is equal to supply. Total
Ach-
demand is equal to total supply. At equilibrium, both the curves are intersecting each other, which means demand is exactly equal to supply. This amount is both the quantity demanded as well as quantity supplied. This means market is cleared. Okay,
Okay.
got
Okay.
Now we will use an example, and using example we will try to understand how actually mathematically we can derive the equilibrium price in a market. Now to do this, we are starting with a single commodity, say X1, and we are defining the demand and supply for this commodity. So the demand function we are defining as D. I think everybody has pen and paper, so at least you write down the equation so that when I'll tell you derive this thing, you will be able to do that. And you will be able to better concentrate too. So please write down at least the equations, not the entire thing because you will get the recording. So let the demand function for the commodity X1 be D is equal to a function of P1. P1 is the price of the concerned commodity X1. Then price of other commodities, suppose there are n commodities in the market. So we are considering price of all n minus 1 commodities. P1 is here, that is the concerned commodity. All n minus 1 prices are here. P2, P3 up to Pn. And we are also considering income of the consumer. Okay, so there are some other determinants of demand too. However, we emphasize on prices of the other commodities and the income, though literally there is taste and preferences, education, geographical location, demographic situation, etc., etc. Equation 1 denotes the quantity demanded of the commodity by X1. That is how much of the commodity X1 the consumers are willing to buy. Okay, so D is giving that. How much of the commodity X1 the consumers are willing to buy. It states that quantity demanded of a commodity depends upon its own price, denoted by P1, prices of other goods, which are basically n minus 1 in number. Total goods are n. So P2 to Pn, and the aggregate or the total income of the buyers or consumers of X1 denoted by Y. Okay, so we are talking about the market demand. So Y is the aggregate income. Y is the aggregate income. Similarly, we are defining the supply function. Supply is a function of S. P1 is the price of the concerned commodity. Price of the other goods we are giving in terms of Q1, Q2 up to Qm. Okay, so there are M number of commodities when we are considering the supply part. Okay, so P1 is here and the rest of the commodity prices are given by Q1, Q2 up to Qm. And there is another factor which we are defining by theta. Theta will take care of technology, etc. In context of supply, we mentioned that when we talk about the determinants of the supply, prices of other goods, that matters, technology matters, input prices matters. So all these things we considered. Okay, so equation 2 states that the maximum amount of X1 the producer wants to supply to the market. This is determined by own price P1. Prices of all the inputs used in this production process are denoted by Q1, Q2 up to Qm, and the technology of production denoted by theta. Okay, sorry, Q1, Q2 to Qm are not prices of other commodities. These are the prices of inputs. So P1 is the price of the commodity, Q1, Q2 to Qm are the prices of inputs, and theta is the technology using which actually the commodity X1 will be produced. So these are the two equations we are considering here. There will be equilibrium if and only if this demand function is exactly equal to supply function. Equilibrium means whatever be the prices of the commodities, whatever be the aggregate demand. On the other hand, if we look at the supply side, whatever be the input prices, whatever be the technology, equilibrium means a state when this D function is exactly equal to the S function. So equation 3 is the equilibrium condition of the model. This implies at any P1 given the exogenous variables. What are the exogenous variables? These P2 up to Pn and income. Similarly, Q1, Q2 to Qm and theta. These are all exogenous variables. So given the exogenous variables D and S are equal, that is all the endogenous variables will be in a position of rest. Now, given this definition of the equilibrium, we are assuming that the demand and supply functions are such that there is a unique and positive value of P1 at which equation 3 is satisfied. There is a unique and a positive value of P1 at which equation 3 is satisfied. If no such price exists, the model is unable to explain the value of P1. Okay, so we need to understand these words, unique, positive value of P1, and the second sentence, if no such price exists, the model is unable to explain the value of P1. We will talk about these things. Okay, so let's move to this part, Okay.
Ma'am, can you please show that slide for a minute?
Yes, one by one, This is the slide.
Thank you.
Ma'am, can you please explain the functions once more?
Functions. The demand function and the supply function.
Yes, ma'am.
Who are you?
Arpan Marginal.
Arpan? We talked about different determinants of demand. Can you remember that?
Yes, ma'am.
Different determinants of demand. Can you remember that?
Yes, ma'am.
So what are the determinants of demand?
I don't remember, ma'am.
You can't remember.
Yes, ma'am.
So you are not checking what is happening to the class. You are there from the beginning, so you have to check all these things. Because I discussed all these things in detail. Price of the concerned commodity, that is the endogenous determinant both for the demand and supply curves. For the demand curve, prices of other commodities and income. These two are also very important. There are several other determinants like taste and preference, geographical location, demographic condition, education, gender, etc., etc. However, to begin with or write the demand function, we are not bringing all those things. As exogenous determinants, we are considering only the prices of other commodities and income. Since this is the aggregate demand, when we are talking about the income, we are considering the aggregate income of the community. Okay, we are talking about a specific market. So in that market, there are several demanders. So Y is nothing but the income of all individuals or the all households, those who are coming in the market. So Y is the aggregate income. Now, when I talked about the determinants of the supply, I considered price as the endogenous determinant that I am considering. I considered input prices and technology as exogenous determinant of demand. So the small q1, q2 to qm are the prices of the inputs and theta is the technology. Okay. So there may be some other determinants of supply as well. However, we are not bringing those exogenous determinants in our analysis. So Arpan, are you now getting it?
Yes, ma'am.
So look at
Ma'am,
the previous lectures, okay, and go through the text. You will understand the matter. Yes, I think there
ma'am,
is one question. Yes.
ma'am, can you once repeat the third point that this implies at point P1, that one?
I didn't explain these things. I am going to explain this thing. I am
It's a
telling
point.
that here I am writing that this one, this sentence
No, ma'am, above that.
above that
Yes, ma'am.
is at any P1 given the exogenous variables D and S are equal. When I am writing these things, I am considering all exogenous determinants, that is prices of other commodities and income for the demand curve, and input prices and technology for the supply curve. These are all exogenous determinants. So I'm considering these exogenous determinants remain constant. These exogenous determinants do not change. From the beginning, I'm telling you, in context of this kind of economic model building exercises, we consider the ceteris paribus situation. Okay, other things remaining constant, when I am varying the price, what is happening? Okay, so these determinants are taking a specific value and it is not changing at all. In this context, equilibrium is a state when the endogenous variables, that is prices of the concerned price of the concerned commodity, and Q, which indicates both demand and supply, these two variables are in rest. So this implies at any P1, P1 is the varying determinant because it is the endogenous determinant. So at any value of P1, given the exogenous variables D and S, that is demand and supply, are equal. That is, all endogenous variables will be in position of rest. So given a ceteris paribus condition in terms of the exogenous determinants, equilibrium is a state when all endogenous variables too will be at rest. Is it now clear or?
Yes, ma'am.
Okay. So,
Ma'am,
yes.
ma'am, when we are considering the prices, then we are considering full price, right?
I didn't get you. Which price you said?
Ma'am, when we are considering the prices as a variables, then we are considering the real price of the commodity, right? Not nominal.
Yes. Yeah. Real price, you know. However, I set the price of other commodities at 1. That is, we are considering a numerator which is equal to 1. Okay. So as
Okay,
such,
ma'am, got it.
there will be no difference between the nominal and the real price when we are discussing all these things. Okay. So we are setting all numerator at 1 so that the nominal price is equivalent to the real price. Okay. Anyone else? Any other question? So now I'm proceeding, therefore, to tell you more about the notion of uniqueness of the equilibrium. Okay, so let me mark the axis first. So this is the quantity axis, this is the price axis, this is the demand curve, and this is the supply curve. Okay, so this is figure 1. This is figure 2. Okay, so what is the difference between figure 1 and figure 2?
Ma'am, the equilibrium price in the first figure is positive, whereas in the second figure, the equilibrium price is negative.
Yes. In other words, both the demand and supply curves are following their properties very well. Demand curves are negatively sloped in both the diagram, whereas the supply curves are positively sloped in both the diagrams. However, the slope of the demand and supply are such in figure 1 so that the two lines are cutting each other in the positive quadrant, which in other words indicate there is an equilibrium or market clearing price which is positive. Okay, because this is the price which is a positive number, say 10, 12, 100, 140, whatever. This is a positive value, so price is positive here. The lines are cutting each other in the positive quadrant so that market clears at a price which is positive. In this particular diagram, both the demand and the supply curves are following their usual slopes. However, their slopes are such that they cannot intersect each other in the positive quadrant, which means that there is no positive price at which the market will be cleared. Okay? So there is no existence of equilibrium price, in case of second diagram, because negative price is only a conceptual thing. Negative price does not exist in the real world. Okay, so there is no price here when there is no positive price here when the market will be cleared. Okay, so here or in this context, equilibrium does not exist, whereas in this context, equilibrium exists. Okay, so in the second context, just and in this case, okay, now moving back to the slide, let's see what we told. This model assumes that demand and supply functions are such that there is a unique, that means 1, and positive value of P1 at which this condition is satisfied. Okay, so this particular point is talking about both uniqueness and the existence of the equilibrium. Uniqueness and the existence of the equilibrium. Okay, so we need a price where the market will be cleared in the positive quadrant. In other words, we need a price. Okay, such that it is positive and the market is cleared at that price. Okay, so too many occasions after Diwali there is Chhat Puja. I think with these micro thing you are also getting the song, you know, so I have nothing to do. Is it very noisy?
No, ma'am, it's okay.
It's okay?
Yes, ma'am, it's fine.
Okay, fantastic. Okay, so this second diagram is marking some problem regarding the existence of the equilibrium. Okay, however, it is not telling anything about the uniqueness of the equilibrium. It is just marking a situation where we are telling that there is no positive price where the market can be cleared. So it is specifically talking about the existence of the equilibrium. However, it is not telling us anything about the uniqueness of the equilibrium. Okay, so now we will go to a second diagram. Is there any question regarding this diagram? Because I'll erase this and draw another diagram.
Ma'am,
Yes.
ma'am, then in the figure 2, what will happen if there is excess supply or excess demand?
If there is excess supply, you know, we are not getting excess demand position in the positive quadrant, isn't it? We are getting excess supply only. If we consider any price like this or like this, in the entire positive quadrant, supply surpasses the demand, isn't it? So
Yes,
if
ma'am, yes.
supply, price will go down. Okay, so price will go down like this. Continuously price will go down. However, we will be never ever able to reach at any equilibrium. So price will continuously fall in this particular type of market. Okay?
Okay, ma'am.
Anything else? Now I'm considering a different type of supply curve. Demand curve I am keeping as it is, negatively sloped demand curve. However, whereas this is the demand. Okay, so in this case, if you look at the diagram, the supply curve is backward bending, first positively sloped and then negatively sloped. Okay, and it is cutting the demand curve twice. On the other hand, if this is the supply curve, several times it is cutting the demand curve. So the equilibrium, you know, demand equal to supply, this position is not unique in nature. Okay, several times we are finding that demand is exactly equal to supply. So the situation is not unique, or equilibrium is not unique. Uniqueness means there is a single point when the demand and supply are cutting each other. Okay. So in this second diagram, there is, say, seasonal fluctuations. Okay. So supply is something less, then it is increasing, again less, it is increasing. So all these things may happen. Okay. And in the first case, so this is market clearing equilibrium. Again, this is a market clearing equilibrium, this point and this point. Okay. Now the first example I have given, that is a very, common example in context of labor supply. Okay, labor supply. Now what happens at the initial stage if wage rate increases, the supply of labor increases. However, we are all human beings, so we cannot work for all 24 hours, or we cannot work for 30 days, 24 hours, or we can work for, the entire year. Always we are working. We need some leisure. Okay. So at the initial stage, as price of labor, that is the wage rate increases or the salary increases, people like to supply more and more labor. However, reaching at a particular point, once salary or the wage reaches at a particular level, in that case, you will, after that, if wage rate or the salary increases, in that case, you will work less. You are getting a very high wage rate. That means you are either doing a very risky job, or you are doing something when there will be tremendous pressure on your brain. Okay. So if the works are like that and you are getting a very high package, in that case, as wage rate increases, you will give lesser and lesser labor. Okay, because the nature of work changes. So this is the context. So what we find that in context of labor supply, though labor demand is negatively sloped, labor supply curve is backward bending. First it increases, then as wage increases, we will like to give lesser and lesser labor. So there will be an inverse relationship between the price and the labor supply. Okay. So if this is the context, if it is a typical labor market, the supply curve is backward bending, we are getting 2 points where the two curves are meeting each other. In the second diagram, there are 4 possibilities when the two curves are meeting each other. So if these things happen, we call the equilibrium is not unique in nature. Now, when we are talking about the typical equilibrium, that is market clears, etc., everything is perfect. In that case, implicitly we are assuming equilibrium exists, which means there is a positive price where the two curves will meet each other, and it is unique in nature. That is, this meeting point will be a single point, not multiple points. Okay, so this figure you can consider as figure 3. Okay. equilibrium, there are two equilibrium, okay, which we call equilibria. So here we are getting multiple equilibrium. So equilibrium exists, however, it is not unique in nature. Okay. So anyone has any question regarding this?
Ma'am, can you explain this one, that how equilibrium exists when it is not unique? I can get that.
Equilibrium means demand is equal to supply. Okay. Equilibrium means the endogenous variables are at rest. Okay. And the aggregate demand is exactly equal to aggregate supply. Now, if you look at point A, what is your feeling? Demand is meeting the supply?
Yes, ma'am.
Okay. Now, if I look at this point, second point B, demand is exactly equal to supply or not?
Yes, ma'am.
Okay. So, equilibrium is a state.
Oh, I got it, man. In this context, it is not being unique, but demand is equal to supply, so it is an equilibrium.
Yeah. Equilibrium exists because they are cutting each other in the positive quadrant. Okay. So, equilibrium exists.
Got it.
Okay. However, it is not unique. In the previous case, we found that equilibrium does not exist because the two lines are cutting each other only in the negative quadrant. So for existence, we need the two curves should meet each other in the positive quadrant. For uniqueness, we need that the two curves will meet each other in the positive quadrant only at a single point. Okay. Now, I'll elaborate more on these points, and to do this, I'll consider two specific equations. Okay, two specific equations. So please write down the demand equation. So I'm giving an example, and with the help of this example, we will like to learn more about the idea of existence and uniqueness of the equilibrium. Okay, so
Ma'am,
let's
one
consider.
question.
Yes.
Ma'am, in the last page, so
Mhm.
can you explain the second graph, please?
In case of second graph, the same idea, however, it is negatively sloped meandering kind of curve. So if the supply curve is like this, it is following seasonal fluctuations, and for that matter, sometimes it is positively sloped, sometimes it is negatively sloped. Okay, in that case, again we are getting the problem of multiple equilibrium.
Yeah,
Okay.
there are 4 equilibrium points.
Yeah, so if we look at if I look at this, in this part, what we are finding, the supply curve is positively sloped. Okay. Whereas in this part, we are getting the curve is negatively sloped. In this part, sorry, positive slope. Okay. And in this curve case, the slope is like this. Okay, so there are points when the curve is positively sloped, when the curve is negatively sloped, positively sloped, negatively sloped. So all these things are happening. It is continuously changing the slope because it is meandering kind of thing. and sometime it is cutting here, 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 here. So the curve is moving like this and cutting the demand curve at several points. Okay, so it is another example when we have multiple equilibria. Okay, so this is more, understandable, because I'll be able to give you concrete example. And in the second case, it is difficult to give concrete real life example, because under certain context it may happen like this. If there is seasonality, in supply of certain commodities, in that case it may be like this.
Is this graph related to the labor supply graph in
Yeah,
any way?
this one is related to the
Yeah,
labor supply.
I'm talking about the second graph. Is it related to the labor supply graph?
No. First one is related to the labor supply, not the second one. Okay. So let's move to this example. So write your demand equation now as a linear demand equation with the form D is equal to A minus A1 P1 plus A2 P2. So write this linear form of the equation. Okay. Now if you look at this equation, P1 indicates the price of the concerned commodity. Okay. And here I'm considering the negative value. That means I'm considering an inverse relationship between P1 and D. P2 I'm considering as the price of other commodity. Okay. And if I take the derivative del D by del P2, what is the value? If I consider the derivative del
P2,
D
ma'am.
by P2, what is the value?
P2.
Value of the derivative, anyone? What is the value of del D by del P1? What is the value of del D by del P2?
Ma'am, del D by del P1 will be minus A1 and this one will be A2. Del D by del P2 will be A2.
So del D by del P1 is minus A1, which indicates an inverse relationship between price and demand. On the other hand, del D by del P2, I'm considering A2. Implicitly, I'm assuming that A1, A2, these are all positive constants. Okay. Now, if I consider del D by del P2 is a positive amount, A2, what is the relationship between the concerned commodity and say X2? Suppose X1 is the concerned commodity for which we are checking demand and supply. So what is the relationship between X1 and X2? Are the commodity substitutes? Are the commodity complementary? Are the commodity not related to each other?
Ma'am, as del D by del P2 is positive, then if P2 increases, then D will also increase. The increment in D will be positive. Therefore,
Yeah,
the goods will be substitute. Because
goods are substitutes in nature. Okay. Price of the other good is increasing. That in turn reducing the demand for that good X2. And that in turn is increasing the demand for X1. It is possible when X1 and X2 are substitutes to each other. So I am purchasing less of X2, I am purchasing more of X1, price of X1 remaining constant. Yes, rightly she has pointed out, here X1 and X2 are substitutes to each other. Okay. So note that all other terms in the demand function involving other prices and the consumer's income are not shown explicitly. So we are not considering all these things explicitly in the equation. Since they are all constants, they are all summed up in A. Okay, so all other determinants, all other factors which may affect demand, we are summing in A, this intercept of the demand curve. A, A1, A2 are all positive constants. They are the parameters of equation 4. Okay, so A, A1, A2, these are the parameters in equation 4. These are the parameters. These are all constants. All constants are positive and they should be considered as parameters of the model. Okay, we are considering the usual negative list of demand curve because del D by del P1 is minus A1. We are considering X1 and X2 as substitutes to each other because del D by del P2 is a positive amount given by A2. Next, we are considering the supply equation. S is equal to B plus B1 P1 minus B2 Q2. Just like equation 4, B, B1 and B2 are the parameters of the model and they are considered to be constants. These are parameters and should be considered as constants. P1 is the price of the concerned commodity, whereas Q2 is the price of the input. Here, explicitly, I have considered one input. Impact of rest of the inputs and technology, all these things have been captured by the parameter B. So impact of rest of the factors have been captured by the parameter B. B, B1, B2 are positive constants. They are the parameters of the model. Now, del S by del Q2, that is equal to minus B2. That is, we are considering the minus sign here. The factor or the derivative, del S by del Q2, that is minus B2. Which means if input price of this particular input increases, usage of this commodity to supply the concerned commodity will fall. If Q2 increases, the supplier will purchase less of this input. If price of Q2 increases, other input prices remaining constant, in that case, supplier will use lesser amount of this input. Okay, it's a perfectly competitive situation both in case of the commodity market as well as in the factor market. So, you know, naturally prices of other factors remaining constant, given that all factors are easily available, supplier will switch to other factor, the substitute of this factor. Okay, so this is the context. Okay, so remember that, or please note down here. Okay, the second thing indicates other input prices remaining constant. If price of the specific input increases, supplier will purchase lesser amount of that particular input. So just as in 4, in 5 also, all other terms involving other input prices and the technology are summed up in B. Moreover, B, B1, B2 are all positive parameters of 5. Okay, all positive parameters. Any question for these two equations? Any question? Everything is clear to everybody?
Ma'am,
Yes.
ma'am, can you explain the supply equation once more? I could not get it.
Yeah, supply equation, if we consider in terms of own price of the commodity, the relation which is stated by del S by del P1 given by B1, that is positive. Okay, that is the market supply curve is positively sloped, because when we are presenting the supply curve, we are measuring price of the concerned commodity along the vertical axis and quantity supplied along the horizontal axis. So if we draw the supply curve, it is a usual supply curve having the positive slope. Okay. However, we are considering the input prices, one particular input price which is given by Q2. Q2 is input price of the concerned input. Okay, say, inputs, if they are marked by, say, Z, in that case, it is the price of the input Z2. Now, we are considering del S by del Q2 to be negative. Since B2 is a positive constant, if I get the value minus B2, it is negative. Now, the negative relationship between S, that is quantity supplied, and input price means, okay, as price of Z2 increases, other things remaining constant, the producer or the supplier will use lesser and lesser amount of Z2. Okay, so if the price of Z2 increases, price of Z2 is given by Q2. If Q2, that is the price of Z2 increases, in that case, suppliers will use lesser Z2 in the production mechanism. Now you got it?
Yes, ma'am. Thank you.
Any other question? Okay. Now at equilibrium, we will be able to equate both the demand and supply. If we go back, at equilibrium, this D is exactly equal to S. D is exactly equal to S. So we can equate this part with this part. Okay. And simultaneously solving, okay, solving that equation, that is A minus A1 P1 plus A2 P2 is exactly equal to B plus B1 P1 minus B2 Q2. Solving this equation, we will be able to derive the equilibrium value of P1. Solving the equation D is equal to S, we will be able to derive the value of P1. So would you please do it on your own? So please write down at equilibrium, capital D is equal to capital S. That is A minus A1 P1 plus A2 P2 is equal to B plus B1 P1 minus B2 Q2. And from there, please find out the value of P1. Solve for P1 in terms of the parameters of the model. Are you doing this thing?
Yes, ma'am.
Yes, ma'am.
Okay, please do that. Now I'll tell Pranjali to tell us the value. Once you get the value of P1, Pranjali, would you please tell us the value? Pranjali, you got it? Ranjali is not there. Shayantani, would you tell us? Anyone else?
May I try?
Ma'am, may I try?
Yes.
Ma'am, P1 is equal to A minus B plus P2 whole bracket A2 plus B2 divided by A1 plus B1.
Yes, very good.
Yes, ma'am, even
Got
I
it?
got the same.
Yeah. So this value you got?
Yes, ma'am.
Yes, ma'am.
Okay. So this is the value we are getting. A plus A2 P2 minus within bracket B minus B2 Q2, and in the denominator A1 plus B1. So please mark it by equation number 7. Okay, so everybody got the value?
Yes,
Yes or
ma'am.
no?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yes, ma'am.
Because what I
Excuse
am
me,
getting,
ma'am.
students are not there. They just give the attendance and they are not there.
Excuse me, ma'am. Ma'am,
Yeah,
ma'am, we could open the bracket also, no, out there, like open the
yeah,
bracket.
you can. But I want to tell you something about the entire thing, and for that matter, I kept the bracket intentionally. Okay,
Yes, ma'am.
so there is
Yes, ma'am.
no harm if you open the
Ma'am,
bracket. However, at this moment, please keep it like this.
ma'am,
Yes.
ma'am, in the equation you were saying the positive parameters of the model, ma'am.
Yeah.
You can say
All
that,
A, A1, A2, B, B1, B2 are positive. Yes.
ma'am, in these parameters means,
I didn't get you. What you are telling, clearly tell me.
ma'am, parameters means in this equation.
A, A1, A2, B, B1, B2. These are all parameters. Do you have any question? Which part is not clear to you? Okay. Now I'll talk more about existence of a unique equilibrium using equation number 7. Using equation number 7, I'll clarify the meaning of existence of a unique equilibrium. For a unique equilibrium to exist, the expression on the right-hand side has to be positive. So first of all, for a unique equilibrium to exist. Okay, so I'm talking about both uniqueness and the existence. So for a unique equilibrium to exist, the expression on the right-hand side has to be positive. That is, A plus A2 P2 minus or B minus B2 Q2 divided by A1 plus B1, that should be positive. That should be positive. From 4 and 5, it follows that the numerator gives the value of D minus S at P1 is equal to 0. So let's move to equation 4 and 5. This is equation 4 and 5. Okay. So would you please consider D minus S at P1 is equal to 0? Please do that. Consider using 4 and 5, derive D minus S at P1 is equal to 0. Once you get it, please tell me what is the value you are getting.
Ma'am, could you repeat it again?
Derive D minus S. Okay, D minus S, and set P1 is equal to 0. D minus S. That means this right hand side of the demand equation minus of this, and set P1 is equal to 0. In other words, I am telling you to derive D minus S at P1 is equal to 0.
Ma'am,
Ma'am, it is A plus A2 P2 minus B minus B2 Q2.
You are getting A plus A2 P2 minus of B minus B2 Q2, whichever
yes,
is the
ma'am.
numerator.
Yes, ma'am.
Yes, ma'am.
Okay, very good. Everybody should get that. If I consider D minus S, we will get the numerator at P1 is equal to 0. So if I set P1 is equal to 0, 0 means I'm considering the horizontal axis. I'm measuring price along the vertical axis. So when I'm telling price to be equal to 0, that means I am along the horizontal axis. Okay, so at P1 is equal to 0, we are getting D minus S, that is given by A plus A2P2 minus B minus B2Q2. Okay, so what I am writing from 4 and 5, it follows that the numerator gives the value of D minus S at P1 is equal to 0. So numerator is giving us the excess demand over the supply at P1 is equal to 0. So D minus S gives the excess of demand over supply, which we refer to as excess demand. Okay, so excess demand when price is equal to 0, it is giving this position. Again, from 4 and 5, it follows that the denominator gives the value of minus del D minus S by del P1. So what now you have to do, you derive the value for D minus S. So do not set P1 is equal to 0. In the equation D minus S, first you write down D minus S, and from there please derive del D minus S. Derive this value. D minus S is already there with you.
Minus A1 minus B1.
Minus A1 minus B1. Other people, are you getting this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
We are getting this? Minus of A1 plus B1. Okay, so if I write, or if I consider minus del D minus S by del P1, I'll get the value A1 plus B1. Everybody, if I consider minus del D minus S by del P1, I'll get the value A1 plus B1.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And this A1 plus B1 is nothing but the denominator in equation 7. Okay, so in equation 7, the numerator is basically D minus S at P1 is equal to 0, whereas the denominator is minus of del D minus S by del P1. Okay, so from 4 and 5, it follows that the denominator gives the value of negative of change in excess demand due to change in P1. Del D minus S by del P1 is nothing but the mod del D minus S by del P1 is nothing but Is it okay? It is change in excess demand due to change in price, P1. Is it understandable up to this?
Yes, ma'am.
Yes,
Okay,
ma'am.
very good. So we are getting in the numerator excess demand at P1 is equal to 0. That is when price is absolutely equal to 0. What is the volume of excess demand that we got in the numerator? And in the denominator, we are getting minus of change in that excess demand when price increases. Okay, so starting from 0 price, when we are moving towards the positive price, that is the price is changing, how excess demand is changing. Okay, how excess demand is changing when the price is changing, that we are getting in the denominator. Next, one sufficient condition for equilibrium P1 to be positive is that the numerator is positive and so is the denominator. Okay, so what we need for the existence and the uniqueness of the equilibrium, there should be a positive single price P1. Okay, so what we are finding, it is given by some value where we have in the numerator the excess demand when P1 is equal to 0. In the denominator, we have minus of change in excess demand when that price increases. Okay, so one sufficient condition for equilibrium at P1 to be positive, equilibrium price to be positive, sorry, equilibrium P1, that is equilibrium price to be positive, is that the numerator is positive as well as the denominator is positive. A positive numerator means at P1 is equal to 0, there is positive excess demand. Okay, that is, if I consider the horizontal axis and if I look at the demand and the supply curve, definitely we should have a position where demand is greater than supply. D minus S is positive. Okay, that is, demand is larger than supply at P1 is equal to 0. A positive denominator means del D minus S by del P1 should be negative, because in the denominator we are getting minus of A1 plus B1. Okay, so if I want to have some positive quantity in the denominator, what we need, that this derivative del D minus S by del P1, that should be negative. Now, del D minus S by del P1 negative, which means as price starts to increase, the excess demand starts to fall. As price starts to increase, the excess demand starts to fall. That is, del D minus S by del P1 less than 0 implies that an increase in P1 reduces excess demand. Okay, so let's try to understand your graph. This is the usual demand curve. This is the usual supply curve. this is price. So, okay, this is the context, you know. And if I set price, this is the price. That's it. That is if price set at 0. Okay. The volume of excess demand is given by this amount. So definitely there is a positive excess demand. This is the demand at the price P1 set at 0, and this is the supply. Okay, so definitely there is an excess demand. Now suppose price starts to go up. Okay, so price goes up. What is happening? This is the supply at this price, and this is the demand at this price. So this is the volume of excess demand, which is sufficiently less than the previous amount. This is the previous amount, and now this is this amount, so it is reducing. Okay, now if the price moves up further to this level, again excess demand is falling. This is the volume of excess demand now. Okay, so this is happening. So for existence and the uniqueness of the equilibrium, we need at P1 is equal to 0, the demand must be greater than supply. That is D minus S should be positive. And as price increases from that level, starts to increase from that level, that D minus S will be continuously get reduced and reduced. Okay, so in other words, for existence,
Can you please repeat this part again? Like you said, it gets reduced and reduced.
yeah, I'm coming to this. Okay, so you know, for existence and uniqueness, first of all, what do we need? D minus S should be positive at that is, if I start with price is equal to 0, at that point, demand should be larger than that of supply. D minus S, which means excess demand, should be positive. The second condition, we need that del D minus S by del P should be negative. Now, what is the meaning of del D minus S by del P? Change in excess demand due to change in price. Change in excess demand due to change in price. So, if I write del D minus S by del P less than 0, this means an inverse relationship between D minus S and P. That is, as price increases, D minus S starts to fall. So as price increases from, say, level 0 to level 1 to level 2, what we are graphically finding that initially this was the volume of excess demand, ED0, coming to this price P1. This is the volume of excess demand, which is ED1, coming to the price P2. This is the volume of excess demand, which is, say, ED2. So what we are getting that as price is moving up and up, the volume of excess demand is continuously falling. As price is moving up and up, the volume of excess demand is continuously reducing. Okay, so the meaning of D minus S greater than 0 means at P is equal to 0, there should be a positive ED means this is point number 1. Point number 2 is as price starts to increase, excess demand starts to fall. Okay. So now check whether you are understanding the two requirements for existence and uniqueness of the equilibrium, or is there any part which I need to repeat? Is it okay to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so let's come back to this slide. One sufficient condition for equilibrium P1 to be positive is that the numerator is positive and so that the denominator. So this is the first point. Second point, a positive numerator means at P1 is equal to 0, there is a positive excess demand. That is, demand is larger than supply at P1 is equal to 0. Third point, a positive denominator means del D minus S by del P1 is negative, which implies an increase in P1 reduces excess demand. So these three sentences are clear to everybody?
Yes, ma'am.
We assume that the values of the parameters of model are such that these conditions are met. So when I am telling that this is the market equilibrium, we are implicitly assuming that the parameters are such that these requirement is met. That is, if price is equal to 0, there is a positive excess demand, and as price starts to increase, the volume of excess demand starts to fall. Okay, next, minus del D minus S by del P1 is equal to A1 plus B1 gives the amount by which excess demand falls per unit increase in P1. Okay, now in this part we considered the change in excess demand. Okay, this thing. Now I'm also considering the negative sign, minus del D minus S by del P1 is equal to A1 plus B1. Okay, or minus del D minus S by del P1 is equal to minus of A1 plus B1 gives the amount by which excess demand falls per unit increase in price. Okay, I'm telling that first, as price is increasing, excess demand is falling. Now, this minus of this is specifically indicating the amount by which excess demand falls per unit increase in price. Thus, we can say that excess demand falls by A1 plus B1 when P1 rises by 1 unit. Excess demand falls by A1 plus B1 when P1 rises by 1 unit. Thus, excess demand falls by 1 unit when P1 rises by 1 by A1 plus B1 units. So, first two sentences are clear to everybody? If there is any confusion, any question for the first two sentences, please ask me. So, is it understandable to everyone? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So, it
Yes,
is a
ma'am.
simple arithmetic. Excess demand falls by this amount when price increases by 1 unit. Alternatively, excess demand falls by 1 unit when price rises by 1 by A1 plus B1 units. Okay. Now, to begin with, at P1 is equal to 0, we had the excess demand given by this amount. A plus A2P2 minus of B minus B2Q2. So, this was the volume of excess demand when price was literally set at 0. So, when P1 is equal to 0, the excess demand was given by this amount. So, excess demand falls by this entire amount with which we began our discussion when P1 rises from 0 to this amount. Excess demand falls by 1 unit when P1 rises by this unit. So, excess demand falls by A plus A2P2 minus B minus B2Q2 amount when price P1 rises from 0 to this amount. A plus A2P2 minus B minus B2Q2 by A1 plus B1. So, check whether this third point is clear to all of you or not. Is it clear? Yes or no?
Yes, ma'am.
Clear? So this explains the equilibrium value of P1. So this is the mechanism. So we will start with the 0 price and we will measure the excess demand at that price. Then price is increasing 1 unit. Okay. Or, from the alternative direction, excess demand falls by 1 unit. If price rises by this unit, and total excess demand we measured that was given by this amount at 0 price. So to eliminate this excess demand, that is excess demand falls by, reduces by this amount when P1 rises from 0 by the amount A plus A2P2 minus B minus B2Q2 divided by A1 plus B1. Okay. Therefore, this is nothing but the equilibrium price. Actually, equilibrium price has been determined following this principle. So, uniqueness, existence, this part is over. Next, we will go for stability of the equilibrium. What is the meaning of stability of the equilibrium? What is the meaning of instability? So we are going for that. So in the next step, we will discuss about stability of the equilibrium. Uniqueness and existence we understood, and now we are going to learn what is the meaning of stability of an equilibrium. So let's have a 5 minutes break and then we will start discussing the stability of the equilibrium. So now if anyone has any question, if anyone is there who did not give attendance, okay, so
Ma'am, I have a small question.
yes, please.
In
Go ahead.
some cases, you start the supply curve from the x-axis a little